I am building the only chemistry lab simulator for the A-level and the O-level students. Yes, the only one.
Why?
Because your practical exam easily comes up to 20% of your overall grades. And the most important thing is, it is unpredictable.
Oh my God.
Students panic, they cry, they don't know what to do about it. And today, you are going to see a live demonstration of my ChemLab simulator, specifically for the qualitative analysis. But first, why build a simulator? Let's just ask Reddit. And this post is from iKali. This person is probably 22 years old already, 6 years ago. This person legit sucked at QA. My Chem mid-year exam prac, I got 9 out of 40. Any tips or tricks on how to do well for QA or Chem Practical in general? And the thing is, she has Chem Practical tomorrow, 6 years ago. And I get it, unlike your other components of your chemistry papers, this is one that you can hardly prepare for. You depend on your teachers to bring you to the lab to try the procedure within the 1.5 hours. If you get it, you get it. If you don't, no remedial. And then what you do? You panic. But that is not to say you cannot prepare for your practical. In fact, outside of playing the chem simulator, outside of practicing in your lab, you can actually study for it conceptually. Yes! Like Milk Tea say over here, 6 years ago, for color change, always state changes from what to what color. And if nothing happens, tell me whether the solution remains the same or no visible change. And if there is effervescence, usually it's those few, and you have to test for all of them. Usually the moment you see bubbles, don't care, just go for everything. In case, in some scenarios we have seen before, there are 2 types of gases coming out from one test. In fact, what Milk Tea is trying to say is what you learn in primary school. Science comes from eye power, observation. And that means when you do any science experiment, you're looking for colors, precipitate, effervescence. Anything that uses your eye, in short. However, that could be a problem. Sometimes colors are ambiguous, sometimes colors are not so obvious. So what do? Let's find out via my Chem simulator. This is my ChemLab simulation game. For all the O-levels and A-level students, the QA is almost sure to happen during your A-level or O-level exams. And for some of you, I understand, this could be the most unpredictable section of your experiment because sometimes the colors are ambiguous, you're not sure what you're expecting, everything is just an unknown. Unlike your titration, usually you can feel title value is around there. And therefore, today, I'm going to showcase to you my ChemLab simulation game right here. So firstly, some basic controls. Just like Counter-Strike, you click, once the cursor is gone, you're inside the game. So moving your mouse, then WASD, just like Counter-Strike, you move around. And you can see all the rest of the controls are on the left, on the HUD. Q is to pick up an item. For example, right now I want to pick up the test tube, there's a ding sound. And then you can add your stuff or you can rinse it. Okay, or you can use a Bunsen burner later. So generally when you press a E is to use the item. And the biggest question here would have to be, well, you've given me a bunch of things. What do? How do I record my results? I hear you, and it's right here. Press the cat button. And you can see you're going to do your test on FA1, FA2, and eventually you could even name the ions present in there, and then you can submit and mark. And today, you are going to see the full demonstration of this. So let's do the first test. Test on FA1, access NaOH. This is the most classic QA test in your O-levels and even your A-levels. The test to identify for your cation ion. So let's take a look at all my solutions. This is my FA1, you can either press E or you can press number 1. It's in your hand and it's green. That could be a clue. So now I'm going to pick up a test tube. And right now I'm going to put in my FA1 first. So this is inside. And then I'm going to look for my NaOH. Not very easy to find from here, but I can just press number 3. NaOH is my hands. So watch this. See that? See that? I even zoomed in for you. You can see a precipitate. Oh! And it turned brown. Very interesting, right? So for your QA, in case you don't know, this is not how you're supposed to judge the color. In fact, I made it easy for you because behind the walls are grey, the walls are white. Usually in your O-levels, they'll give you a white tile. If not, for the A-level students who don't have them, always bring it to your light, press F, and you can see the clear contrast. So now I have my results. What can I say? I press my tab, I just say green precipitate formed. Okay, green precipitate turns brown after standing. So this part is done. From here I have a choice. I can choose to wash it, and I can do again. If not, I can put it back, and then the game continues. And because this is the demonstration, let me use another test tube. So let's pick maybe number 2. So number 2, FA1 again, you're going to test H₂O₂. For students who have done your H₂O₂ test, you more or less know you're expecting effervescence, and most importantly, you're expecting oxygen. So let's go and try it. So FA1 again is green. Then you're going to take your H₂O₂, which is number 6. It's in my hands. So probably have to use a splint at some point. So just take a look at the key. It says 0 for splint, so just get ready for that. So I'm gonna put it in. There's effervescence and you hear the sound effect and it turns brown. So firstly I'm gonna say green solution turns brown. Effervescence. Observe. Then now I'm gonna close first. I'm gonna do my test. Now realize that the gas is gone. So what can you do? Just like a real experiment. Add more, add more, add more. So now I'm faster gonna take my splint. I light up. Oh, wrong key. Oh no, I missed it again. Okay, so again I'm gonna take my FA1. Take my H₂O₂, number 6. Put it back. Press 0. Light it up. Insert. Nothing happens. So I'm probably expecting like oxygen. I'm probably expecting oxygen, so again I'm going to put the lighter splint down first. So this time I have to do it fast. Okay. So, and then I insert. Can you see that? It really likes a glowing splint. So I'm going to record it down right now. So, reignites glowing splint. And that's done. So there's a lot more experiment. You're gonna see me continue. Finish up my FA1. So throw in my splint, press R. So in this case, I want to show you that you can put it back and you can still see everything is still there. So now I'm gonna take another test tube. Second test, gonna take my barium nitrate. So barium nitrate, I choose to add my barium nitrate first, but then I can add my FA1 after. And you can see straight away, there's a green solution that forms a white precipitate. So you can see the interaction here is not just following the instructions. Just like a real experiment, you could reverse it and then you could still see the same kind of observation. Of course, I forgot my HNO3. Put it in, but I don't think it makes a difference. You should know what it's for by now. So put it down, record it. Green solution forms white precipitate. Done. So again, I can put this back to show you that it works. Next test tube. Acidified AgNO3. So you should know what this is testing for. Chloride. So FA1. So I put in my AgNO3. Let's see whether there's a white precipitate. There is. You can see right here. So again, gonna write it down. In fact, I'm gonna copy and paste. Saves me time. Close. Just like that, my FA1 is done. I have a secret to share with you. For the past 2 months, I've been working hard day and night on this game, and this game is catered to the H₂ chemistry students. We all know your A-levels is a highly competitive exam. It's a high-stake exam that will affect your future in terms of determining where you go from here. Whether it's NUS, NTU, SMU, or even, like my former student, Oxford. And for every component of your A-level exam, most of the time, it's about repetition, it's about the amount of effort that you put in, it's about the amount of time that you dedicated. However, one component is clearly not the same, and that component could be the biggest differentiator in terms of separating you from the B students, and that is the H₂ chemistry paper for the practical exam. Because unlike every other component where you can do the papers at home, the practical component is about practicing your experiment skills, knowing exactly what to do, even though you could be shaking for your life. And in schools, you're limited in terms of how often you visit the lab, how often you get to practice the experiment, and sometimes it's just doing it once and you move on. And therefore, I have a solution. For you and my students, I have developed multiple stages of individual experiments before developing the prelim exam. Meaning, in this prelim exam module, all the experiments will be laid out for you. You will be tasked to do all 3 experiments before answering the questions, all while having the same real interaction and failure that you would experience in a real lab scenario. And that means you'll see color change, you see precipitate, you even see effervescence. This is as real as it can get, and nobody else out there is doing this. So if you're passionate about getting the A for your A-level H2 chemistry, and you want to be able to work on the component where most of your friends do not have access to, such that by the exam you'll be very confident walking into the hall, knowing that you probably secured about 100% of your practical component in your H2 chemistry exam, so that you have the highest chance of scoring an A for your actual A-levels. Wait no more. Sign up today and you get a lifetime subscription to the game. Now, back to the video. So now, back from the break, moving on, we're gonna continue for Fa2. Now this one is rather tricky. If I just look at all the tests, sodium carbonate, if this is a positive test, this will showcase the most difficult part about this game, which is your delivery tube with the rubber bunk. And then finally your AgNO3, then NH3. I suspect this got to do with a complex. So let's try the easy one first. Let's do the litmus paper and we'll see where it takes us. So let's take a solution. Litmus paper is right there, or I can look for the key. So I want to test with a red litmus paper first. I put it in. Nothing happens. So I change to a blue one. So put it down. Oh. So put it down. Gonna change to a blue one. Let's see. Right there, it turned red. So I'm gonna record it. So blue litmus turns damp blue litmus paper red. And I'm done. And now I'm gonna add my AgNO3 and ammonia. So AgNO3. You see it? There's a white layer down there. That's your white precipitate. But let's see what happens if I add the NH3. So maybe put it here, I zoom in, and I add. And it dissolves. So how am I going to record this? So I'm going to say white PPT forms, dissolves in NH3, excess ammonia. And that's done. Now imagine this being the night before your O-levels. You get to practice this over and over again, that you get to try the entirety of all the QA tests. Just imagine how well prepared you will be ahead of your friends for your national exams. So now let's try the hard part. This one is a bit special because it's the carbonate, so I need to set up a bit differently. So you can see there's a test tube here, test tube 8. This one is a Limewater. So what happens is you need to pick up the bunk. Okay, then you're going to assemble, put it on a test tube, and now you see it's assembled. Okay, very interesting stuff. So right now I'm gonna put Fa2. So Q, Fa2. So right now I'm gonna add in my carbonate and faster put it back. So carbonate in hand. I can zoom in first. Oh, there's carbonate. So now time to observe. So you can see it says the milky white PPT is observed. So I can put it up. You can see it turns to form the white precipitate. So now I'm going to write it down. So effervescence, observe, white PPT formed in lime water. And now this is the exciting part, to fill in all the blanks. So Fa1, based on everything, it should be Fe2+. And Fe2+, it got oxidized to Fe3+. Again, we saw in the first two tests. And then eventually you have your sulfate. And you also have your chloride. That's interesting, isn't it? So in this case, I don't know whether silver sulfate is insoluble or not, but I guess I'm just going to put in FeSO4 first and see what happens. And this is like a real practical. Sometimes you have to make a choice. Sometimes your solution could have multiple cations or multiple anions. In this case, they asked me directly for the final compound. This would be my guess. Next one, Fa2. Probably some acid that reacted with a carbonate, and then this white PPT dissolves in excess ammonia. That's an interesting thought. Why would this occur? I'll have to guess some form of acid that would do this. Silver nitrate is not going to be a white precipitate. Silver chloride could be a white precipitate. And then eventually it forms a complex because of the silver. I'm just going to write AgCl. And this is the moment of truth. Submit and mark. And you can look at the marks. This is 11 out of 19. Now this is the part where you have to exercise judgment. Because when this game was produced, it's not very easy to ensure that the game is able to come to the consensus and work around your answer to see whether it really works. Sometimes it's just one-to-one matching. If it doesn't match one-to-one, they may mark you wrong. And therefore you have to exercise your own judgment, a good form of revision for yourself. is this answer they written good enough? So for the first one, you can see I got only 2 out of 3. They wanted gelatinous. I can't really tell that, but if you ask me, I think my answer is good enough. Let's look for one that is completely wrong. Why did I write AgCl for Fa2? I already said it's acid, right? So dilute HCl lah. Okay, so technically I got most of it correct. Where was the part that was wrong? The sodium carbonate, I did not say that it was CO2. This one really depends on your school. I've been told that some schools ask them not to identify the gas even though you know what it is and simply just record the observation. Other schools will ask you to record the observation and also identify the gas. So that's very, very interesting. Now this game is not perfect. Truth be told, this is the second stage that I produce. For the rest of the stages, I make incremental improvements. So as you go further and further with me in this YouTube series, or if you choose to purchase this game, you're gonna start to see that the game will start to have drop-wise mechanism. You can see that the game will start to have more interesting colors. You can see that the game will have more interesting experiment that has occurred in real brilliant papers, but you may not have gotten to try, and in fact some of them are really challenging, not just for me to code, but also for you to perform. So this is truly exciting. So what are you waiting for? Your A for your chemistry practical is waiting for you behind this game. Nothing else. This is Yao from Vantage Tutor, the class above the rest. Take care. So some basic... Hey, but wait, okay. But wait, this program precipitate. Oh, add more. So now I'm faster gonna take my splint. I light up. Oh, wrong key. Oh no, I missed it again. So, wash everything again. See, I also need to get used to the game. So let's try again. So number 6. Hey, I took the wrong solution. Sorry guys. And then I insert. Eye power.